Hello students of S1A and S1B. Actually, we were discussing sequence questions in the last class and some kind of sequences were left, like I had to discuss cubic sequence as well, but because of short of time I could not have discussed there. But now I am going to complete this question and some other kind of sequences like cubic and some other kind of sequences, and then I'll solve some examination questions as well, so you can better understand and better grasp the concept well, and you can practice from past examination questions yourself. You can download papers from any GC pastpapers.com, or there are so many websites there. Past paper questions are available, so you can practice from there, or you can practice exercise questions and get well prepared for your assessment on Sunday. Okay, so this is what we were discussing in the last class. We had already discussed so many example questions and arithmetic sequence, how to make a formula for it, and the alternative methods as well. And then we switched to quadratic sequences and discuss the method how to find out quadratic sequence. And I was doing another question, and by that time uh, our class was ended. But now I am going to solve it for you, so you can just go through this video lecture and then you can solve questions from past papers as well. I'll do some example questions from past papers as well. So I'm going to complete it first. Actually, we were discussing this sequence and we were going to find out the nth term formula or general term formula for this particular sequence. So first of all, we checked the differences of first order differences. They were not coming constant, they were also increasing. uh, and then we checked the second order difference, it came constant. So half of the second order difference becomes the coefficient of n square. So minus 5n square is the first part of the formula, and the later part is to be found after making a sequence of 5 minus 5n square ourselves, and by setting different values of n we can make a sequence of minus 5n square. Like if I set n as 1 in this expression, 1 square is 1, that multiplied to minus 5 gives you minus 5. So first term comes as minus 5. Then the second term, n is tried as 2 in this expression, so 2 square is 4, and 5 4s are 20, but its negative sign makes it minus 20. And the next term is like 3 square. If we set n as 3, 3 square is 9, 9 multiplied by 5 is 45. Sorry, 9 5 is 45, yes, and negative sign makes it minus 45. And the next term we can try 4. 4 to the power 2 gives you 16. 16 into 5 is 80, but minus sign makes it minus 80. So this is our sequence that gives us answers of minus 5, minus 20, minus 45, and minus 80. But if we check with the original question is dealing with 2 instead of minus 5 in first term, minus 13 instead of minus 20 in the second term, minus 38 in the third term, and minus 73 in the fourth term. So I have to just check what am I supposed to do with this, my answer of minus 5 as generated by minus 5n square, the first part of my formula. What am I supposed to do with it in order to make it equal to the first term of the original question? So it is simply minus 7. Sorry, it's plus 7. My pardon. It's plus 7. Okay. If I add 7 to my answer, it makes it equal to the answer given in the first term. So try the next one also. Again, it's plus 7 gives you, if you add 7 to minus 20, it gives you minus 13. Again, it is plus 7 gives you minus 38. Again it is plus 7 gives you minus 73. So in this example, these numbers are coming constant. So there is no need of formula making for this part. You can directly state your answer. So in this case, you can directly answer as general term or nth term is simply minus 5n square plus 7. That's it. Because every time minus 5n square is generating some number, in every term we have to add 7 to it in order to make it equal to the answer in this particular sequence which is already given in the question. So minus 5n square plus 7 is your answer directly. Okay, so this one is easier question. I think I have already discussed it, but I just completed it in my notes as well. So I should move to the next part now. Now for the cubic sequence. So for cubic sequence, cubic sequences are given in simple form, not so difficult form. Generally, cubic sequence can be made in like ax cube, an cube plus bn square plus cn plus d, but that kind of complicated sequences won't come in your syllabus. Only simple questions will appear. Like if I give you an example, generally they appear like this. N cube plus a, where a can be positive constant value or negative constant value. This is the form that comes in your exam. Okay, for example, n cube plus 1 or n cube minus 3, etc. So this is how you can find the sequence of cubic expressions. Okay, now try some question here. If I take an example, how do you identify that this is neither an arithmetic nor a quadratic sequence? Like if I give you some sequence of numbers, like I'm making a question actually, which is related to similar kind of situation. If I try something in my calculator, I'm not going to tell you what am I going to assume the expression. Minus 4, 3, 22, 59, 120, and so on. So this is the sequence that we have to find out the formula behind. So how we can solve this kind of question, because it's not mentioned in the question whether it is cubic, quadratic, or which kind of pattern is there. So how do you understand its pattern? First of all, you should try the differences as we normally do. What is the difference between these two numbers? It's plus 7. Or you can try 3 minus negative 4, that gives you second term minus first term gives you the difference. Okay, and then we have plus 19, if I'm not wrong. And then 59 minus 22, 37. And then 120 minus 59 gives us 61. And if you check the second order difference, how much it is? It is plus 12. And then it is 37 minus 19, it's plus 18. And again, it's not coming constant, as you see. 61 minus 37 gives you plus 24. If you try further order difference, you can see it's coming plus 6 and plus 6. So this is coming constant in third order. So if we have third order difference constant, like this is first order difference, this is second order difference, not constant. First order, neither first order nor second order constant, but third order is coming constant. It means the formula behind is something in cubic form. Okay? And you can try one thing. I want to tell you that in this case, for cubic case, you can try one approach, that 1 by 6 of the third order difference, third order constant difference is coefficient of n cube. Okay, just like in arithmetic progression, what constant difference comes, that becomes the coefficient of n. In quadratic, half of the second order difference becomes constant. In third order difference constant or cubic, 1/6 of the third order constant difference becomes coefficient of n cube. And then you can make a sequence of 1/6 of third order difference constant. So in this case, it would be 1/6 of 6, so it's 1. So 1 times n cube. That is actually the first part of the formula. From this information, from this formulation, you can try 1/6 of second order difference constant, third order difference constant becomes the coefficient of n cube. So it is now n cube. 1n cube is the formula of the first term. First term of the formula is n cube or 1n cube, same thing. Now you can make the sequence of n cube. If you try n as 1, it comes 1. If you try n as 2, it's just like similar as you did in arithmetic progression, also in quadratic progression. So this is actually similar kind of thing. So you are making, first of all, you have find the first term of the formula. In arithmetic progression, the constant difference coming in the first order difference, if it comes constant, directly make it the coefficient of n. If second order difference comes constant, it is actually quadratic formula behind. So half of that second order constant difference becomes the coefficient of n square. In case of cubic sequence, you can make 1/6 of the third order constant difference as coefficient of n cube. This is what I did here. 6 was coming constant in the third order, so I made 1 n cube or simply n cube as the first term of the formula. Now you can make the sequence of n cube by trying different values of n. When n is 1, 1 cube is 1. When n is 2, it is 2 cube, that is 8. When n is 3, it is 3 cube, that is 27. When n is 4, it is 4 cube, that is 64, and so on. And 5 cube is 125. So this is my results of values that are coming from n cube. And now I can try compare it with original question. My original question says -4, 3, 22, 59, 120. So my values are not exactly coming same. So I should note it down here: -4, 3, 22, 59, and 120. -4, 3, 22. -4, 3, 22, then 59 and 120. So how can I make my result equal to -4? Simply I have to do one thing, that I can subtract 5 from it. And see, in the next term also subtract 5. In the next term also subtract 5. Subtract 5. Subtract 5. So in every term we are subtracting 5. Therefore we can conclude Tn as n cube minus 5. That's your answer. Hope you get it. So we have discussed till cubic sequence, and there should be another example of it that is a little bit more challenging, and I do not believe that this kind of question will come in your examination, but at least for the completion of the concept it should be done. So I'm taking another question now on cubic sequences. Like we have a question. Find the nth term of sequence 0, 37, 134, 321, 628, and so on. And we have to find formula for nth term. So in this kind of question, you have to always try the same way as you studied in the previous examples. That what we do, first of all, we check the differences. If we check the differences, this is 37, and it is 97, and then it is 187, and then it is 307. Not coming constant, try the next difference: 60, 90, and 120. Try another time: 30 and 30. Yes. So we have third order difference constant now. So there is some cubic formula behind which is generating these numbers, and that is actually required to be found out here. This is the first order. Which is not coming constant. Second order, again not coming constant. Third order difference is coming constant. It means there is some cubic formula behind that is generating these numbers, or we have to find out that cubic formula. Now we have the way, as I told you, Alhamdulillah, excuse me. So we have 1/6 of this third order difference, it is 5. Alhamdulillah, excuse me, 5. So the first part of the formula is 5 n cubed. Now make the sequence. Alhamdulillah. Actually, I am not feeling well, but it's necessary that I should discuss these questions as well with you. That's why I'm taking out some extra time for you. Okay. So 5n cube. First, third order difference constant is multiplied with 1 upon 6. Whatever comes is to be placed with n cube, and then make a sequence of 5n cube and then compare it with the original sequence. So if you set n as 1, 1 cube is 1, 1 multiplied by 5 is 5. That is the first term of our established first part of the formula as 5n cube. And if we set n as 2, 2 cube is 8, 8 multiplied by 5 is 40, and then 3 cube is 27, 27 multiplied by 5. Then 40 and 135, and then 320 and 625. You can try different values of n. N as 1 gives you 5. If you put n as 2, it gives you 40, because 8 into 5 is 40. And then you have to put 3, 3 cube is 27, 27 into 5 is 135. And then 4 cube is 64, multiplied by 5 is 320. 5 cube is 125, multiplied by 5 is 625. So we have these results, and now you should copy the original sequence under it and then compare your answer 0, 37, 134, and I should copy here. This is original sequence 0, 37, 134, 321, 628. Now you can check what am I supposed to do with my numbers in order to make them equal to the above numbers. So what am I supposed to do with this 5? Subtract 5. What am I supposed to do with this 40? Subtract 3. What am I supposed to do with this 135 minus 1? What am I supposed to do with this 320 plus 1? What am I supposed to do with this 625 plus 3? And now you can observe that these numbers are making another sequence. If I pick it up and place here, minus 5, minus 3, minus 1, plus 1, and plus 3. So they are making another progression. So just check whether the first difference is coming constant. Plus 2 gives you this, plus 2 gives you this, plus 2 gives you this, plus 2 gives you this. It means there is some arithmetic progression behind. So you know how to deal with arithmetic formula. So common difference comes with n, so 2n. And what am I supposed to do with this value? If I set n as 1, this answer comes as 2, but the original sequence is minus 5. So what am I supposed to do with 2 in order to make it minus 5? Just only subtract 7. So try in the next one also. If you take n as 2, it becomes 4. When you subtract 7 from it, it comes minus 3. So this is the second part of the formula. And this was the first part. So put them together in order to state your answer as general term formula. 5 general term Tn, nth term 5n cube plus 2n minus 7. Hope it is clear. So this is how cubic sequences are dealt with. And now come to some other kind of sequences. Like I should write it on next page. Sometime we have other kind of questions like a to the power n or a to the power n minus 1 or any format of similar format of a to the power n plus b, where b would be any number like minus 1 in this previous step. Okay, so this kind of sequences if this kind of sequences come, how do you identify? Keep your method same, always try first order difference. If first order difference do not come constant, try second order. If it is not coming constant, try third order. Even if it is not coming constant, then you should try to go for power sequence, okay? Or power, these are also called power sequence, okay? Power sequence. So I give you one example here, like question is 1, 2, 4, 8, 16, 32 and so on. So it's obviously a simple question. You can easily identify that these are the numbers that are increasing with powers of 2. Every number is like twice of the other. Okay. So if I try 2 to the power n, then my answers are coming like 2 to the power 1 is 2, 2 to the power 2 is 4. So it's not matching with it. Okay. You can try one thing. If you try 2 to the power n minus 2 to the power n minus 1. So it gives you 2 to the power 0 as 1, 2 to the power 1 as 2, 2 to the power 2 as 4, 2 to the power 3 as 8, 2 to the power 4 as 16, 2 to the power 5 as 32 and so on. So this is actually the formula 2 to the power n minus 1. Okay, so this is how you deal with power sequences. I think I should do one more example for your practice. And giving another question, doing another question of course, like another question is write the nth term formula for 5, 11, 29, 83, 245. Okay, if in examination this kind of question comes, so first thing that pops up in your mind that you cannot have a look of it and you can identify, just like in previous question you have already observed that these are some powers of 2, but it was starting from 2 to the power 0. So every time you should subtract 1 the power, so n minus 1 was the power. But in this example that I am going to do right now, you cannot guess like this. So how you do if you do not know which category of this sequence is? So first you try in the same manner as you did in the previous questions, that you first try the differences. So if you try differences, plus 6 plus 18 plus 54 plus 108, sorry, 162. So not coming constant, try second order. Second order is like 12, 36, 108. Try third, because second order is not coming constant, 24 and 72. So it's not coming constant. So if you try common differences, you do not find up till 3 order, then it won't be like 4 order or something else. No, that kind of question you do not expect in your examination at your level. So you should try some number to the power. So try to write powers of 2 and 3 and 4 and then check, compare with your original question. I try for 3 to the powers. So I am going to try for power 3, 3 to the some powers, just like constant to the some power as in the whole description, some number to the power. Okay, so try some number to the power and then compare it with the original question sequence. Let's try with 3 to the power n. If you put n as 1, it becomes 3. N equals to 2 gives you 3 square is 9. Then 27. 3 cube is 27. Then 81 and 243. These are different powers of 3 that I have illustrated here. And now check with the sequence given in the question: 5, 11, 29, 83 and 245. So what am I supposed to do with it in order to make my answers exactly equal to the question answers? I have to add plus 2 in this number, I have to add plus 2 in this number, I have to add plus 2 in this number, plus 2 and plus 2. So it's obvious that every time I have to add plus 2 to it. So it's so simple that I can conclude my final answer as 3 to the power n plus 2 is the general term, or nth term in this sequence. Okay, hope it's clear. So we have like I'm just going to summarize each and everything that we have discussed in sequences. First of all, we have arithmetic progression, or arithmetic sequence. For arithmetic sequence, first order difference is constant and it becomes the coefficient of n. Let's suppose this is value a. So a n plus b is the general term. Where b can be concluded after setting some value of n over there. Like if I write some sequence and give some example: 34, 39, 44, 49 and so on. In this sequence, every time we are adding plus 5, plus 5, plus 5, so simply 5n is the first part of the formula, and you just list the values of 5n with different values of n. 5 is a 5, 5 2 is a 10, 5 3 is a 15, and 5 4 is a 20. And check the original sequence, how it is running. 34. So what am I supposed to do with this 5 in order to make it 34? I have to add, how much I should add? If I add 30, it becomes 35, so I should add 29 to it. Now try the next one. Next one is 39. I have to add plus 29 again. The other one is 44 and 49, and you can check every time you have to add 29. So simply 5n is the first part, and every time you have to add 29 to it, so general term is simply 5n plus 29. In the same way, for quadratic sequence, we have for quadratic sequence, second order difference constant, and this number is half of second order constant difference becomes coefficient of n cube. Like, I should take another example here. We have some numbers available in a sequence. For example, we have a sequence of results 2, 17, 42, 77, and so on. So you can try the differences first. Plus 15, plus 25, plus 35. So first order is not constant, so try the second order. Plus 10, plus 10. So half of this number, half of 10 is 5. This becomes coefficient of n square, 5n square. With different values of n, you can put n as 1, so it's 5, n as 2, so it becomes 2 square 4, 4 5 is 20, and then try 3 square is 9, 9 5 is 45, try 4 square is 16, 16 5 is 80, and then check it, compare it with your original sequence. Original sequence is 2, 17, 42 and 77, and now just check what am I supposed to do. Minus 3, minus 3 minus 3. It means every 5n square results should be, 3 should be subtracted from every member of 5n square. So the general term 5n square minus 3 is the general term. Okay. Now come to cubic. For cubic we have like let's suppose I am taking an example here. For example, we have to find nth term in the sequence. First of all, I should write the rule as I wrote for arithmetic and quadratic. So I am going to write a rule here first, and I write these numbers. 1/6 times third order constant difference is coefficient of n cube. So try with this example, like minus 6 comma 1 20 57 118 and so on. So in this case, if you try, the difference is minus 6 to 1, it's plus 7 plus 19, and it is like plus 37, and then 118 minus 57 is 61. And now try second order difference. It's plus 12. It is like 37 minus 19, 18 plus 18, 61 minus 37 is 24. Again not coming constant, so try third order. So it's plus 6 plus 6. So we have third order difference constant now. So you can try one thing, that you can use the formula of 1/6 of third order difference as coefficient of n cube. I'm just going to write over there. I'm going to write here. So we have third order constant difference is coming as 6. So 1/6 of 6 is 1. 1/6 of 6 is 1. Therefore 1 times n cube is the first part of the formula. And if you try n different values of n, 1 into 1 cube is 1, 1 into 2 cube is 8, 1 into 3 cube is 27, 1 into 4 cube is 64, and 125. 1 into 5 cube is 125. Now you can compare it with the original pattern of numbers given in the question: minus 6, 120, minus 6, 120, 57, and 118. 118. So how you can compare these two results together and now check what differences are coming. I'm going to write a different color so you better understand. What am I supposed to do with this 8 to make it 1? Oh sorry, this is left. No problem. Minus 7, minus 7, minus 7. Is it? Yes, minus 7. So every time I have to subtract 7 from all answers of my n cubes. So general term is n cube minus 7. Is done. Now come to the last one, that is a to the some power or a to the some power to the power 1 minus 1, like I think that is already done. I should do some past examination questions with you so you can better understand how to deal with this. These are already discussed here on the same page. So on this page only I have discussed most of the methods but not all. These are only helpful tools that can give you an idea how to deal with exam questions, and after doing all these practices you can easily deal with the exam questions. I'm sure about it. So now I'm going to solve some exam questions for you so you can better understand, grasp concept well, and you will be able to take your class test successfully. Okay, so I'm going to solve these questions now. I've already picked up some questions from past papers. I'm going to share here. Share it with S note with this file. So this question is copied here. Now we can see the question, what it says. This is actually a reference is given. Feb March 19. You can see a reference here. It's paper number 42. 2 is actually for region. Paper number 4. Your syllabus code 0580. And it is assessed in 2019 February March. Okay. So how do you solve this question? First see the question. The table shows the first 5 terms of sequence A and B. Term 1 has, like the whole table is given, 7, 13, 23, 37, 55. So you have to guess the next term. Okay. So you have to complete this table first, and then sequence B says 1, 3, 9, 7, 21. So you can easily guess the next term yourself. So if I come to the next part, nth term of sequence A, then how do you find nth term of sequence A? First of all, you should see the numbers and take their differences. 7, 13, 23, 37 and 55. So what is their difference? Difference is plus 6. Next difference is plus 10. Next difference plus 13. Next difference is sorry, it's not plus 13, it's plus 14. Plus 14. And the next difference, you can observe that first time we added 6, then we added 10, then we added 14. So the next would be added with 18, and you can try with the help of your calculator as well whether it is the same sequence that we have found. 55 minus 37, it's 18. Yes. So the next number can be guessed without finding the formula. So you can complete this table before finding the formula. next number must be 20 ahead of it. So it's obvious that the next term can be guessed easily. So plus 22, sorry, plus 22. Every time we are adding 4 to it. See, second order difference is 4. So there is some quadratic formula behind. It's obvious that 2n square plus something is there, right? So 2, because half of the second order difference becomes the coefficient of n square. So 2n square is the first part of the formula. And you can guess this term yourself because plus 22 gives you 77. So it's obvious that next term is 77 here. And now you can try 2n square, 2n square, because half of 4, half of second order difference is 2. That becomes coefficient of n square, and it's 2n square. Now different values of n and compare with the original sequence. N1 gives you 2, and 2 square is like 4, 4 multiplied by 2 is 8. 3 square is, for third term, 3 square is 9, 9 to the 18. And the next term is like 4, 4 square 16, 16 to the 32. So original question says 7, 13, 23 and 37. So every time, see, every time you are doing the same operation, that is plus 5. Okay. So every time if you add plus 5, you get the same answer. So the final answer is 2n square plus 5. Okay. And then the next term and next sequence is easier. 1, 3, 9, 27, 21, 81. It's clearly seen that these are some powers of 3. If you want to waste your time in differences, you can, but obviously 3, 7, 9, 27 and 81 are the powers of 3. But whether it is 3 to the power n or 3 to the power n minus 1 or 3 to the power n plus 1, this is actually a little technical that you should try. But you can guess the next term as 80, after 81, next power comes as 243. So every next number is multiplied by 3, right? So you can directly guess the next term. So 3 multiplied by 81 is 243. But in order to make the sequence, you should see first term is not 3. If it were 3, then 3 to the power n generates 3, 9, 27, and then 81 and so on. But the first term is not 3, first term is 1. It means it's starting from 3 to the power 0. So 3 to the power 0 means 3 to the power 0, 3 to the power 1, 3 to the power 2, 3 to the power 3, 3 to the power 4 and so on. So you can write your formula as 3 to the power n minus 1, because in first term you have to keep power 0. So if you take n as 1, 1 minus 1 becomes 0, so 3 to the power 0 becomes 1. 3 to the power 1 for second term you should try n as 2. So 3 to the power 2 minus 1, 3 to the power 2 minus 1 means 3 to the power 1, so 3. So the next term is 3 to the power 3 minus 1, 3 to the power 2, that is 9, 27, 81 and so on. So this is the formula for 3 to the power n minus 1. Okay. Now we have next part also. Nth term of sequence this is given. Find the second term. This is so simple question. Just try 2 over here, 2 square. For second term, n is 2. So put it in this formula. So 4 times 2 square plus 2 plus 3, and that's your answer. 4 to 16, 16 plus 5 is 21. So 21 comes here. The value of n, where the nth term is 498. So this is actually the formula for Tn, and the value of Tn is also given in this question, directly given, but n is required. So just put it like this. In place of Tn you can write 498, and n is to be calculated. So n is 4n square plus n plus 3 equals to 498, and solve for n. 4n square plus n plus 3 minus 498 equals to 0. This becomes 4n square plus n minus how much it is? 495 equals to 0. Now try quadratic formula or breaking the middle term to find the values of n. I am just directly trying with the quadratic formula. Under root b square minus 4ac upon 2 times a. So you can use your calculator to find these answers. If I check with the help of my calculator, what my calculator gives, for x square plus x minus 495 equals to 0 and solve. My answer is coming 11 and 0. N equals to 11 or 0. 0 not allowed. The only answer acceptable is 11 because number of terms can never be 0. Okay. So 11 is my answer. So this is how you can solve this question. It's done. And I should check my answers as well, whether my answers are coming correct or not. I already have answers copied here. These are the answers. I'm going to share this recording as well as this document with you on Google Classroom. Recording will be only YouTube link because it's difficult to upload these long video files. So I am just going to upload this PDF form of these notes on Google Classroom directly and only reference of YouTube link for your consultation. See, my answers are exactly matching with the answers given here. (77) 243 2n square plus 5 3 to the power n minus 1 21 and 11. So my answers are exactly matching with it. Okay. Now come to the next question. One more question I'm going to do from past papers. This is actually May June 19 variant 42 of your same past papers. Now it is going to be pasted. Yes, it is here. I should cut it from here and place it on the same page where I was working. So this question comes here. Now I have to solve this question. This is also question number 11. See, every time it comes as last question. Most of the time it comes as last question of the paper, like question number 11 of paper 4. Question 11 of paper 4. Okay. And this question is like diagram 1, diagram 2, diagram 3, diagram 4, diagram 5. The sequence of the diagrams above is made up of small lines and dots. Complete the table. First we have to complete the table, and then n is term formula is to be made, and there are some other extensions of the part questions. So first of all we have to complete the table. So if you check, diagram 1 has 4 number of small lines that are line segments which are connecting this figure. In diagram number 2 there are 10 such lines. In diagram number 3 there are 18 lines. In diagram number 4 there are 28 lines. And you can count in diagram number 5 yourself, or you can observe the sequence, how this sequence is running. If I write here what is going on here, plus 6, and then plus 8, and then plus 10. So you can guess what should be the next, plus 12. And you can confirm from counting the number of line segments on original diagram, and I hope they would definitely come same. So it should be like 40, and the next should be 54, because the same formula should be carried forward to the next term as well. Like this one should be plus 14. And see, its first order difference is not coming constant, second order difference is coming constant, plus 2, plus 2, plus 2, plus 2. So there is some quadratic formula, and plus 2 is there, so half of that, n square is the first part of the formula. Okay, this is actually what we are going to work for the next part question as well, but first we are going to do this table completed. What is going on here? Plus 4 plus 5 plus 6. So you can guess next one, plus 7, further next plus 8. So plus 7 gives you, and obviously this is also not first order difference constant, so it is also some quadratic formula, and constant second order difference is coming plus 1, plus 1, plus 1, plus 1. So second order difference is coming constant is plus 1, and half of that that becomes coefficient of n square. So half n square is the first part of the formula of second sequence of number of dots. You can count number of dots in first diagram are 4, in second diagram there are 8 dots, in third diagram there are 13 dots, in fourth diagram there are 19 dots, in fifth diagram you can count them yourself, or you directly do it by this sequencing. You should verify your answer every time. I need not to, that's why I am skipping that counting work. That's tedious work. I am not going to waste my time, and I am recording this lecture, so I have to save my time. So it's directly I am doing 25. Is it 25? No, sorry, it's 26. 19 plus 7 is 26. Now add 8 to it, so it becomes 34. So we have already discussed half of the part of this discussion. For diagram n, find an expression in terms of n for the number of small lines. Means only for this sequence we need to have a formula, not for the next one, although we can build it, but it's not required. Okay, so second order difference is coming constant, plus 2, plus 2, plus 2, plus 2. It means n square is the 1n square, half of 2 is 1, half of 2 is 1. So this is the coefficient of n square, as you see here. So n square sequence should be made with n values as 1, it gives you 1, as 2, it gives you 4, as 3, it gives you 9. For 4, 16. For 5, it's 25. And check what numbers are stated there. The numbers stated there are 4, 10, 18, 28, 40, and so on. So what am I supposed to do? Minus 3 here. Here I have to do like minus 6, minus 9, minus 12, minus 15. So this minus 3, minus 6, minus 9, minus 12 and minus 15 has another sequence of constant difference of minus 3. So minus 3n is the first part, and then minus 3n gives you n. If n is 1, it gives you minus 3. So what am I supposed to do with this? Minus 3 is coming same. If you try next one, like n equals to 2, it's minus 6, directly coming the same. So there is no need of making this sequence. It's obviously direct answer coming minus 3n. So minus 3n is directly second part of the formula. This one is the first part of the formula. So n is square minus 3n is your answer. Hope you understand that. Now come to the next diagram. R has 108, 300 small lines. We made the formula for small lines, yes. And now we have a final answer of number of lines. Means general term is given. Term number is required. R is required. So this is actually R's diagram. So if they are saying R, you should write TR as R square minus 3R. I am writing the same formula, but n is replaced by R because the question required so. But the number of small lines, the question is based on number of small lines that we have worked on and we have built the formula. Now they are replacing the variable from the name of n to R because this is actually what they try to find out as value of R. And term is already given. Some term has this number of small lines. You have to find the number of term, means n is to be required, or in this question particularly R is required. So 10300 equals to R square minus 3R. That gives you R square minus 3R equals to, sorry, I'm just shifting this 10300 on other side, so it becomes minus 1030 equals to 0. Now try quadratic formula to find your answers. R equals to, or you can split in the middle term if you can. Making factors of 10300 is quite longer to work, so it's better to try with quadratic formula. Plus minus under root minus b plus minus under root b square minus 4ac upon 2 times a. So it will give you answer of this quadratic equation. I am just solving it directly from my calculator to save my time. In calculator I can write x square. Listen, variable is just like a dummy, whether it is n, r or x, it doesn't matter. So in calculator you can write it in terms of x. X square minus 3x minus 10300 equals to 0, and I am going to solve it. 11, x equals to 103 and 0. 103 and 0 is coming 103. So my answer is coming 103. Let me check my answer. for this part, for this question. I think there is some calculation error in this equation. But you can solve quadratic equation, I believe that's not a problem. So try it yourself, you'll find correct answer, that's not a problem. I had to tell you how to deal with these questions. I'm just going to place it in my document so I can share you. So what my answer is coming? 54, 34, sorry, 40, 54, 40, 54, 26, 36, yes, 26, 34, sorry, 26, 34, yes, n square and minus 3n. N square minus 3n or n times n minus 3, both are the correct answers. And this C answer is not matching, so you can check your with the help of your calculator, you can check this answer yourself. It might not be coming correct with my solution, so you can just check it yourself. Quadratic solution is your problem. How do you deal with it? There is another part of this question that I did not copy here, that might be related to this second sequence, is general term formula and then finding n term. So if you have done this, you can understand the next part as well. So hope it is done, and I have given you so much details regarding these questions, and we have done past examination questions as well. So there are so many different ways how question can appear in your examination. Now you should understand that. Thank you, students. Wish you all the best for your test on Sunday. And I am not going to take your class on Zoom on Sunday. You have to simply download your paper and solve it and submit me the scanned copy of it, or however you do submit your paper. Thank you, students. Allah Hafiz. Bye-bye.